Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. This is part 4 or 5, I think part 4, of the same problem of two bodies starting with the same initial speed, going towards each other and free falling. And we did already 3 methods, and we find the time when they meet is 5 seconds, and they meet actually way below where the first body is started. So notice I never put here ground, because I know that on the ground it's impossible, because on the ground the first body will reach the ground in 2 seconds, and the upper body, the second body, will be still somewhere high and they will not meet. So over time, they meet in 5 seconds, and it would be below the first body, 75 meters down the first body. And we did it graphically, and I will now remove those graphs, and I will remove this formula about x1 and xt, because it's not really that important. Because all I want to discuss here is velocity, speed, the graphs of speed. And remember, I was talking all the time that the area underneath the graph of velocity is the distance. And so I actually want to bring home this situation here. So we have v, right? And we have time. And we have important time is 1 second. Important time is 2. It's important because it's the maximum point the first body reaches the apex in 1 second. And then in another second it's back at the same point where it started, and then it's going down with the same velocity v0 that it started, but it's directed down. And then there is another 3 seconds, and in 5 seconds, the body is at minus 75 meters. And so all I want to do, I want to say that this body, it starts with a speed 10. This is 10, right? And the speed, let me write it for the second body, it's the first body. V1, this is the first body. V1 equals V0 minus GT. So this is a straight line, and this should go like that. But there is a trick. By the way, if I look here and I say what's time t, v0 minus t time 1, this would be, if t equal 1, it would be 0. So this is a straight line. When t equals 0, it goes here 10, and when t equals 1, it would be 0. So this is a straight line that goes like that. And this is absolutely true, only I need the area, and I'm not concerned with the sign, so I actually have to turn this up. I actually have to turn this out, and it goes like this. And this would be the areas that I'm interested. So this is a true speed that I'm not really interested, but I'm interested in this area, and I'm interested in this area, and I'm interested in this whole area. And let's calculate this area, but for that we need to understand that when we come to here, this is 10, right? Again 10. And in 1 second we change g multiplied by 1, so 10. So basically, if this is 10 and this is 4 times bigger, then this whole distance, would be 40, right? Because 10 is here, another 10 will begin in another second, another 10, and finally in those 4 seconds this will be the total thing. So we can calculate the area, right? Let's calculate this area. This area is triangle, 1 multiplied by 10, right? Divide over 2. It would be 5. So this area is 5. Let's calculate this area. 4 multiplied by 40 dividing 2. Divided over 2, so it would be 2 by 40, it would be 80. So this would be 80. So we fly 5 up, then we fall 5 down, so we end up at minus 75. Again, we go up 5 meters, and this is exactly what is here, so it's good. Then for another second we fall down, come here, this is another 5 meters, and this 5 meters we have to subtract from this 80. So 80 minus 5 becomes 75. And we are good. And let's draw now the graph. Let's wipe it out. And let's find this, draw the graph of the body that's going down. It's a second body. And this is V1, V0 minus GT. And this would be V2, right? V2 and again, we're calculating the area, so we can direct our speed, like we can put negative speed and then put it the mirror version because it's absolute value. But I'm calculating speed, I'm calculating distance as a surface, so I'm concerned only with positive numbers. So if for this body V I put the x here, then V2 would be V0 plus GT at any moment. So it would be 10, and it would be gaining like this. And this whole area, because it doesn't change any direction, would be this thing that it covers. And it covers, we know, 175. So we have to receive 175 for this area, for this body, right? And so let's continue. I suggest we can calculate this area in many, many possible ways. Or for example, we can draw this line. Oops! We can draw this line, and we can say that this area of this rectangle is 10 over 5. So this is 10 over 5, because it's 5 seconds and it's 10, right? And then in 5 seconds, I will remove this 40. In 5 seconds, it was gaining 10 meters per second every second, so this is 50. This one is 50. So then I know that this area of this triangle, the whole triangle from here to here to here, is this, which is 5, multiplied by this 50 and divided over 2. It would be 5 by 50, 250 over 2. 250 over 2 is 125. So this area of this triangle is 125. And what I did now wrong? Probably nothing, because 10 multiplied by 5 would be 50. So this rectangular is 10, 50. This triangle is 125. So 125 plus 50, it would be 175. And it is 175 meters from here, so 100 meters here and 75 meters to here, and we basically solved, sorry about that, it's my chalk, and we solved this problem with another way, going through the graph of velocity and the area underneath the graph of velocity, and we have to be very careful because when we're calculating distance we only want to take a positive section of the graph, because we're not calculating the coordinate, we're calculating the change in velocity, the distance. So velocity has to be positive. That's why we put this x for the second body and we get this picture. And this concludes this problem. I promise there would be no more permutation on this problem unless you ask me a question, and unless you ask me something similar to this, then I put it in this playlist. But for the time being, that's all that I can tell about this problem. But I will have way more. Subscribe, bell, like, and see you next time. Thank you.